third part of the session that we have today. We discussed about a dichotomy in attentional processing from top-down and bottom-up attentional processing. And I think that is going to be important in terms of having an understanding about these two major types, and then we'll discuss about the top-down in the next steps together. So we know that a stimuli like a snake is going to activate the top-down or bottom-up? The bottom-up process. And with activating the amygdala, we discussed about the pathway before. And it's quite interesting. If we filter out a significant level of information from the figure or the stimuli, they can still activate the pathway. So we know that even with subliminal presentation of a stimuli, they can still activate amygdala. And sometimes even we cannot see the picture. Can just show you the pictures in just few hundreds of milliseconds, and that is going to be really hard to differentiate. And even there are something like a few tens of milliseconds. They can show you those figures without being able to, without letting you to see them, but you can still have the activation in amygdala. And even for drug use disorders, they can show you drug-related cues for few seconds, few tens of milliseconds, and you do not see anything. So you do not have any, let's say, conscious reporting, but you still have activation in your ventral striatum and in parts of the limbic system. So that is amazing that how bottom-up processing is engaging different parts of the brain in a really efficient way, even with just milliseconds of presentation. But technically what we have for attention training and conscious attention and voluntary attention, it is basically the top-down attention that we discussed about. And it seems that there are different parts of the brain involved in terms of, let's say, frontal eye field. These are the parts of the motor cortex that are involved in controlling the eye movements, and see that controlling the eye movement is going to be critical in terms of controlling attention. We have superior parietal lobule, we have inferior parietal lobule. These parts, it seems that these parts are doing the attentional control part, and then the attentional control parts basically control what we call the targets of attention. So those visuotropic maps, or the patterns or the representations that we discussed before that could be encoded in different parts of the cortex, how we move from these different activated maps or different kind of organizations of information or mental representations, this is going to be managed by the controlling parts of the attention, and probably these parts are controlling which part of these, let's say, targets of attentional control would be modulated. So that is one really simple model of, let's say, describing what we call top-down attention. But there are some other models in terms of how different parts of the brain are involved in top-down attentional control. We discussed about the model of, let's say, having frontal, parietal, and limbic systems involved in top-down control, and then mainly the visual processing, and then amygdala and striatum involved in bottom-up, and then we discussed about the arousal process. But the models could get a little bit more complex as well, like this model I'm showing you here, in terms of when we talk about attention, the reticular activation system is going to make arousal. We discussed about this before. But for attention, we can have different exploratory part, perceptual part, and motivational part. In terms of why should I pay attention to a specific item, it's about the motivational part. And how I can shift my attention to different parts, or the exploratory part, and then the perceptual part, which would be related to, okay, what are the parts in the visual, in the kind of piece of information that should be targeted in the process of attention. So there could be a combination of different pieces that are working together. As you can imagine, we discussed about the role of kind of superior colliculus before in terms of the visual processing, and how superior colliculus is an important part in terms of managing the frontal eye field and managing eye movement. So wherever we have significant eye movement modulation by attention, superior colliculus would be involved in this process. So people try to develop different sorts of models describing how different components of attention are being processed in the brain, and how different items within these kind of, let's say, model would be contributing a role in the process of attentional processing.